Every device connected to the internet has TCP/IP installed on it. TCP/IP is based on the concept of layers, which is simply a section of the process that has a specific job to do. It's like being on a production line of a car. The first person will add the wheels, the second the engine, and so on. Once the car is finished with the first person, it's passed on to the next. With TCP/IP, the idea is that a packet will be handed to a layer which will do something to it and then pass it on to the next layer. Just to be clear, a packet is a small piece of an overall piece of data that we're transmitting. We don't transmit data in one big chunk, but as lots of little pieces that can be reassembled at the other end. There are 4 layers to understand: application, transport, network, and link. Let's say you want to send an email. We will start with the application layer. The application layer will decide which application protocol to use, for example SMTP, and the software, such as Outlook. It will then pass the data down to the transport layer. The transport layer will split the data up into packets and add a packet number to each of them. It will also establish the length of the packet. The numbers are so we can reassemble the message in the right order at the receiver. The transmission control protocol is the protocol which handles this process on the transport layer. However, as we learnt last lesson, UDP is an alternative to TCP and could be used in this layer instead. TCP will perform some additional actions that UDP won't, like setting up a connection between the hosts that are communicating and adding additional data to the packet. Transport will then hand the packets to the network layer. The network layer will add the source and destination IP addresses to the packets. The Internet Protocol is the protocol which handles this process on the network layer. The network layer will now pass the packets down to the link layer. The link layer will add headers and footers and the MAC address of the sender. It's also responsible for converting the binary message into either electrical signals for a wired network, light for a fiber optic network, or radio waves for a Wi-Fi network. The link layer can then transmit the data. At the receiving end, this process happens in reverse. First, the packets will arrive at the link layer. The link layer will receive the packets, strip the headers and footers, and pass the packets to the network layer. The network layer will check to see if the destination IP address matches the IP address of the device. If it does, the packet's source and destination IP addresses are stripped off and the packets are passed to the transport layer. If not, the packets are sent back to the link layer to be put back onto the internet. Again, the Internet Protocol is the protocol which handles this process on the network layer. At the transport layer, the number of packets received are checked against the total number of packets. The packets will also be checked for errors. If any are missing or damaged, the receiver will ask the sender to retransmit the missing packets. If not, the packets are reassembled and the message is passed up to the application layer and the receiver gets your email. Again, the Transmission Control Protocol is the protocol which handles this process on the transport layer. The purpose of the TCP/IP stack is to guarantee that your packets will be delivered. If the packets are not for the target machine, the network layer will check the destination IP address and put it back on the internet. This will keep happening until the packets arrive at the correct computer. If any packets have errors in them or any are missing, the transport layer will ask the sending computer to send them again. This makes sure that all packets arrive intact and guarantees that you get your data sent. So, the TCP/IP layers are made up of application, transport, network, and link layers. Application decides the software and protocol for data transmission. Transport breaks the message into packets and adds packet numbers. Transport also checks for errors and missing packets on the recipient side. Network adds sender and recipient IP addresses. It also makes sure that the packets have reached the correct machine on the recipient side. Link adds MAC addresses, headers and footers and puts the packets onto the transmission media.